So here I am working out the 10.2 problems. Can't over recommend you do all of these. Use formula and definition, construct fourth order Taylor polynomial at x equals 0. F of 0 equals 1. F prime of 0 equals, the derivative would be 1/2 times 2x. Those will cancel. 1/2. That's a chain rule for the inside. 1/2, 1 plus x squared to the negative 1/2. Plug in 0 and you get 0. F double prime of 0 equals, and they got some work to do, low d high, high d low, all that fun stuff, because this will come down. Square root of 1 plus x squared times 1 minus x. 1 plus x squared is the negative 1/2. Sorry, I'm thinking. Right, so this was square root of 1 plus x on the bottom, so it comes up, derivative of x, then x times the derivative of basically square root of 1 plus x squared. X, again, the 1/2 and then negative 1/2 cancel out. All over 1 plus x squared. Plug in 0, you get 1. Plug in 0, you get 1. Plug in 0, you get 0, 1. And do I have to do one more? I do. Let's see. I'm being really skeevy about shortcutting this. You've got x squared times 1 plus that over 1 plus x squared. I am going to shortcut this. Hopefully you follow along. We'd be doing a lot of this on an opposite page. Negative 3x, 1 plus x squared to the negative 5/2 x, the negative 5/2, which is going to be 0. So I happen to know that f of 4 of 0 will equal negative 3. Where did all that come from? You're going to have to do some of that work off to the side. I don't quite have enough space to do it here. So fourth order polynomial is 1 plus 0 plus x squared over 1 plus 0 plus 1 x squared over 2 factorial plus 0 minus 3x to the 4th over 4 factorial equals 1 plus x squared over 2 minus 3's will cancel, x to the 4th over 8. Or you could have just left it like that one up above. All right, here we go again. F of 0 equals 1. F prime of 0 equals 2 times 1, 2. F double prime of 0, I'm sensing a pattern, equals 4. F triple prime of 0 equals 8. F fourth of 0 equals 16. P4 of x equals 1 plus 2x plus 4x squared over 2 factorial plus 8x to the 3rd over 3 factorial plus 16x to the 4th over 4 factorial. You can leave it like that. Nothing, absolutely nothing wrong with that. If you're one of those people who likes reducing it, 1 plus 2x plus 2x squared plus 4x to the 3rd over 3 plus 2x to the 4th over 3. And you can see why I wouldn't do that if I had to write general term, if this went on forever and ever. I can do it here, but I can't really do it here. But over here, I kind of can. Anyway, lots and lots of math. Find the formula in the definition of the fifth order Taylor formula in the Taylor series for the function of x equals 0. we go. F of 0 equals 1/2. F prime of 0 equals negative x plus 2 to the negative second equals negative 1/4. F double prime of 0 equals 2x plus 2 to the negative third equals 1/4. F triple prime of 0 equals negative 6, x plus 2 to the negative fourth equals negative 3/8. F fourth of 0 equals 24, x plus 2 to the negative fifth equals 3/4. And one more, because why not? F of 5 of 0 equals negative 120, x plus 2 to the negative 6 equals negative 15/8. So P5 of x equals 1/2 minus x over 4 plus x squared over 4 times 2 factorial plus negative 3x to the third over, hang on, getting lost in my math here, 1/4 found a mistake in my answers. 8 times 3 factorial, negative 3/8, 8 times 3 factorial, yep, plus 3x to the fourth over 4 times 4 factorial minus 15x to the fifth over 8 times 5 factorial. Perfectly happy leaving it there. If you feel like it, interesting. You can actually keep going if you're looking, because there's no pattern there. If you're looking for a pattern, and you would get 1/2 minus x over 2 squared plus x squared over 2 to the third minus x to the third over 2 to the fourth plus x to the fifth over 2 to the fifth. Yeah, cool, huh? Oops, a mouthful, I missed one. X to the fourth minus x to the fifth, 2 to the sixth. Crazy math. Oh, I love my e's. They're so much easier. F of 0 equals e. First, f prime of 0 equals negative e. F double prime of 0 equals, shocker, e. F, you know what, you probably don't need to write all this out, but I do not trust my brain. You should not trust my brain either. F. Now, 0, 2, 4, even, other ones are odds. So the fifth order polynomial, e minus e to the x plus e to the x squared over 2 factorial minus ex to the third over 3 factorial plus ex to the fourth over 4 factorial minus ex to the fifth over 5 factorial. You could factor out e and go crazy here. I'm done. And I can write a pattern from that if I need to. Sure hope I had that on screen the whole time. Use the table of Maclaurin series to correct the first 3 non-zeros terms. Oh, this is much better. Because I can just throw in these. So we have ln of 1 plus x. Interesting. So ln of 1 minus x means that all these terms are negative. Yeah, so negative x minus x squared over 2. Well, what happened to 2 factorial? That's not the, go back and look at your list. And that would be, the next term would be negative x to the n over n. Now, it doesn't say here, but that means you're starting with n equals 1, infinity of negative x to the n over n. And you check it out, you plug in 1, yeah, that works. 7x e to the x means just multiply an extra 7x to the e family. So 7x e to the x equals 7x plus, and we're not multiplying 7x every time, just once times what was there. 7x squared plus 7x to the third over 2 factorial plus 7x to the fourth over 3 factorial plus 7x to the n over n minus 1 factorial. I don't like that. Sum of n equals 1 infinity 7x to the n. First, second, third. Oh, that's right. We threw an extra n in. Otherwise, we'd go 0. Yeah, all that nonsense. N minus 1 factorial. 0, 1, 2, 3. There we go. Okay. X squared cosine of x equals just an x squared times all those terms. X squared, the first term was 1, minus x fourth over 2 factorial plus x to the sixth over 4 factorial plus dot, dot, dot. Alternating, negative 1 to the n, x to the 2n plus 2. Yes, you could factor out the 2 if you wanted, over 2n factorial. And again, I've got to write this down because we're starting at 0 this time. Always checking it out. 0, see ya. 0, 2, 0, see ya. Next term. 1, yep. 4, yep. 2, yep. Next term. Gone. 0, 1, 2, the second term. 4 plus 2, 6. 4, good. That works. Oh, I just realized I'm forgetting the interval of convergence. Yeah. Negative 1 less than negative x less than 1. Divide everything by negative and then flip it around. You get 1 is less than, negative 1 is less than, x is less than 1. Oh, my bad. This is at that, and then when you spin it around, it ends up on the other side. Interval of convergence. Factorial on the bottom. Works for everything. Factorial on the bottom. Works for everything. E is going to be, works for everything. So e to the negative 2x equals 1 plus negative 2x plus negative 2x squared over 2 factorial plus negative 2x to the third over 3 factorial, also known as negative 1 to the n, 2 to the n, x to the n. Yes, I could have smashed them together. Over n factorial equals sum from n equals 0, 0, 1, 2 factorial to infinity. Negative 1 to the n, 2 to the n, x to the n factorial, IOC, all real numbers. Practice, practice. All right, find the Taylor series generated by the function e to the x over 2 at x equals 1. F of 1 equals e to the 1/2. F prime of 1. Now notice it doesn't say the number of terms. So I got to just do enough so I can see the pattern. E to the 1/2 over 2. F double prime of 1. E to the 1/2 over 4. All right, let's write the sucker, see what I can do. I'm going to put a T up here because it is a Taylor series and I don't put a number here. X equals e to the 1/2 plus e to the 1/2 x minus 1, we're centering it somewhere else, over 2 plus e to the 1/2 over 4 x minus 1 squared over 2 factorial plus, and I didn't write these up here, but again, now I think I know what's going on, x minus 1 to the 3rd over 8 times 3 factorial. So equals sum from n equals, I think I will go with 0, e to the 1/2 x minus 1, 0, 1, 2 to the n over 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the n times n factorial. Yeah, it's hard, I know. That's kind of the point. If it was easy, I think the whole school wanted to be Calc, but it's not, it's hard. From 10 through 12, find the Taylor polynomial. 4 to 3 generated by f at x equals 0 and x equals 1. Okay then. A is pretty easy. P3 of x equals x third minus 2x plus 4. Challenge me, Mr. T. Okay, well, here you go. All right, so f of 1 equals 3. F prime of 1 equals 3 minus 2, 1. F double prime of 1 equals 6x, 6. And f triple prime of 1 equals 6. So 3rd degree polynomial equals 3 plus 1 times x minus 1 plus 6 times x minus 1 squared over 2 factorial plus 6 x minus 1 the 3rd over 3 factorial. If you want to finish there, you're fine. Or you could write 3 plus x minus 1 plus 3x minus 1 squared plus x minus 1 to the 3rd. Multiply that out, you get a 1 out front. So it looks, if I just do a very brief first term check, looks like it works. Off we go. 3rd order. You might say, well, what's going on here? I'll get there. Okay, just checking my work. So P 3 of x equals -2 plus 11 times x minus 1 plus 14 x minus 1 squared over 2 factorial plus 12 x minus 1 to the third, 3 factorial. You can be done. Or you can go crazy like me. Whew. What I call working for a living. This is hard. Yeah, we're getting there though. All right. What's the third order polynomial for this? There isn't one. All right, so what's the third order approximation for this going to be? Well, f of 1 is 1. F prime of 1 is 3. Oops, 4, because I can't add. Multiply in this case. F double prime of 1 is 12. And F triple prime of 1 is 24. Okay. Third degree polynomial. 1 plus 4 times x minus 1 plus 12 times x minus 1 squared over 2 factorial plus 24 x minus 1 to the third over 3 factorial p to the 3x equals 1 plus 4 times x minus 1 plus 6 times x minus 1 squared plus 4 times x minus 1 to the third. That'll approximate this. Will it be perfect? I don't know. Plug in 1, we get 1. Plug in 1, we get 1. How about plug in 0.9? Well, play with it, see what you get. It's tough. It's hard math. For 13 and 14, find the Taylor polynomials. Order 0, 1, 2, 3, generate f at x equals a. Alrighty. F of pi over 4 equals root 2 over 2. F prime pi over 4 equals root 2 over 2. F double prime pi over 4. I think we've done this before. Equals negative root 2 over 2. So we're going to have this triple prime pi over 4 equals negative root 2 over 2. And off we go. So, hey, what would we get as an approximation if we just did a 0th term? Get that. Hey, what would we get if we did the first term? Root 2 over 2 plus root 2 over 2. X minus pi over 4. It's centered over there. Oof, getting messy. How about the second term? We get root 2 over 2 plus root 2 over 2, x minus pi over 4, plus root 2 over 2, x minus pi over 4 squared over 2 factorial. Bring this down, just make that 4. Or the third one equals root 2 over 2 plus root 2 over 2, x minus pi over 4 plus root 2 over 2. And no, I was going to say I'll just combine them. No, I don't want to do that. The fourth over 2 factorial plus root 2 over 2. Oh, I forgot my negatives. Oof. That's what happens with these problems. You start going crazy. Negative. 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 X minus pi over 4. What does that say to the fourth? To the third over 3 factorial. Sorry about that. It's hard. This is not easy. Okay. F of 4, and now we're approximating square root, which we've done with linearization. That's a problem I see often on the AP exam. They say, hey, use this. Now try this. Now try that. And derivative is 1 over 2 root of x, which is 1/4. And so on and so on. F double prime of 4 equals negative 1/32. F double prime, triple prime of 4 equals 3 over 256. P naught of x equals 2. Good approximation. What if we put in 4.1? Let's look at 2. Not so good. P1 of x equals 2 plus x minus 4 over 4. P2 of x equals 2 plus x minus 4 over 4 minus x minus 4 squared over 32 times 2 times 3. Yeah, that's probably asking too much of my brain right now. 32 times, not 2 times 3, just 2. And then P3 of x equals 2 plus x minus 4 over 4 minus x minus 4 squared over 32 times 2 factorial plus 3 times x minus 4 to the third over 256 times 3 factorial. Yeah, I think I found another mistake in my notes, but this one's correct. I'll leave that up there for a sec before we shed some tears and then move on to the next problem. 2 more pages, not too bad. This was the worst of it. By the way, I'm telling myself that, not necessarily the viewer. FP function, derivatives all orders, f of this, f prime of that, right third order polynomial, use an approximate f of 0.2. So this is what I started hinting at before. We're going to approximate it and see how well we do. All right, let's give it a shot. So P3 of x equals 4 plus 5x minus 8x squared over 2 factorial plus 6x to the third over 3 factorial. Let the calculator do the dirty work. Plug in 0.2. This is centered at 0, so 0.2 should give us a pretty good approximation. 4.848. Unfortunately, we don't know what to compare it to. We're at the second order polynomial. Use it to approximate that. No idea what they're just asking me to do. Just take the derivative, and then use that to approximate the derivative at 0.2. Great. So there's no real rhyme or reason why we're doing what we're doing. We're just doing it. Whatever you say. So f prime P prime of x, I think would be a more accurate way to write it, even though I really don't like it, would be 5 minus 2's cancel, 8x, 3 cancels these 2 and leaves 3, plus 3x squared. And then p prime of 0.2, which has nothing to do with this. This is third order of the original function. This is second order of the derivative function. I'm just following the rules. Hey, these numbers are no, that doesn't mean anything. They're just getting you comfortable with this. It's a lot. Maclaurin series for f of x, find f prime of 0. Okay, I can do that real easy. 0, 1. Oops, forgot to do the derivative. My bad. I thought it was f of 0. F prime of 0, that's gone. Everything else is gone. I get 1/2. And then f of 10 of 0 would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Let me show you what I mean here. I take the first derivative, that term's gone. I go to the second term, and the x drops, and I get 1/2. Now, if we're doing the 10th one at 0, I dropped the first term when I did the first derivative. We're going to drop the first 10 terms. So the only thing we're going to have is the 11th term. The 11th term, when n goes in, is 11. 1, 2, 3, 4. 11 plus 1 would be 12 factorial. So I think I'm off by 1. Oh, I'm doing the 10th term. My bad, not the 11th. So I did the first derivative. What's the second term? When I do 10th, I go to the 11th term. So I plug in 10, but it's the 11th term. So confusing. 11 factorial, which is 1 over 11. And more goofy math just to keep you on your toes. Start to figure out those terms, what's going on there. U of x equal x f of x. And by the way, this is the same problem. Write the Maclaurin series showing the first non-zero terms and the general term. G of x equals x plus x squared over 2 factorial plus x to the third over 3 factorial plus dot 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 plus x to the n plus 1 over n plus 1 factorial. And I have this habit of plus dot 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 of writing starting at n equals 0 because I don't want there to be any miscommunications. And then write g of x in terms of a familiar function. Okay, familiar function. Yeah, that's e. G of x is x times that. So let's see if I can figure it out. No, that's not. It's not. That's not. It's 1 plus x over 2. So let's see what's going on here. 1 plus x plus. Okay, so this is g of x. It's e of x, but it lost the 1. How would you know that? You wouldn't, unless you saw it. Okay. F of x equals this stuff. Find the first 4 terms in the general term for the Maclaurin series generated by f. F of 0 equals 2. F prime of t equals 4t over 1 minus t squared. F prime of 0 equals 0. F double prime of t equals all this nonsense. And when I plug in 0, I get 4. So rather than keep going, I figured out that with the calculator, F123 of 0 equals 0, and that's kind of obvious. That happens with these problems. 4 equals 48. So the fourth order polynomial about t, because why not, equals 2 plus 0t plus 4t squared over 2 factorial plus 0t to the third over 3 factorial plus 48t to the fourth over 4 factorial equals 2 plus 2t squared plus 2t to the fourth dot 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 2t to the 2n 1, 2, 3. Now starting at 0. Yeah. Starting at n equals 0. So yeah, 0, 1, 2. Yeah, that works. Wow, that's some serious math, huh? Find the first 4 non-zero terms, the Maclaurin series for G. G is the integral. This is the kind of stuff you'll see on an AP exam. So G of x equals the integral from 0 to x, f of t dt, which is the integral of 0 to x of 2 plus 2t squared plus 2t to the fourth plus 2t to the sixth plus dot 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 dt. G of x equals 2x plus 2x to the third over 3 is 2x to the fifth over 5 is 2x to the seventh over 7, 2x to the 2n plus 1. We just added 1 to this one up here over 2n plus 1. Starting at n equals 0. Yeah, that works. Always check. That's what I was just doing in my head. Yeah, that works. All right, so notice that the power series, blah, blah, blah. Hey, they define this recursively. Cool. Find the first 4 terms, the general term of the series. So we just start listing them based on what they tell us to do here. 1 plus 3x, x plus 3 halves, 3x squared plus 3 halves times 9 halves times x to the third. 1, 2, 3, 4. So now I got to go find a pattern. 1 plus 3x plus 9 halves x squared plus 27 x to the third over 4 plus dot 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 plus, well, it's 3 to the n, 3 to the first, second, so it's going to be starting at 0, x to the n over I got an n factorial. I don't know if I buy that. Oh yeah, I see it. First off, this is 3 over 3. My bad. Got to follow the rules. And so that's 2, 3 times 2. It's going to be 4 times 3 times 2. That's 3. That's 27 over. This is not 4 because I didn't read it right. 6. All right. 2, 3, 0, 1, 2, 3. Yep. N factorial. Dot dot dot. N starts at 0. What function is represented by this power series? Well, we got an n factorial on the bottom. We're looking e to the x, sine of x, cosine of x. Well, this is e right here. So if 3 keeps getting powered up, then it's e to the 3x. It's the exact value f prime of 1. Well, f prime of 1, since I know this, is 3e to the 3 times 1. 3e to the third. Wow, that was physically difficult. Yeah, but you got to put the time in if you want to get good at this stuff. Good luck.